This problem is about divisibility rules, so let's review a couple of them. We'll start with divisibility by 8. A number is divisible by 8 if its last 3 digits form a number that is also divisible by 8. In this case, its last 3 digits are 5, Q, and 6. So depending on the choice of Q, this gives us several different possibilities. It could be 506, 516, 526, 536, 546, 556, 566, 576, 586, or 596. If you test all of these numbers to see which are divisible by 8, you'll see that only 536 and 576 are divisible by 8, which means that our possibilities are Q equals 3 or Q equals 7. Now we need to look at divisibility by 11. A number is divisible by 11 if the differences of alternating sums of its digits is divisible by 7. This is a little bit harder to understand. It's more involved, so we're going to look at an example. Let's consider 11,979. If we start with the first 1 and look at the alternating digits and add them up, we have 1 plus 9 plus 9, which equals 19. If you look at the other set of alternating digits, the ones in between, that gives us 1 plus 7 equals 8. And if we take the difference between those sums, 19 minus 8, we get 11. And because that's a multiple of 11, we know that the original number was also divisible by 11. If it's not a multiple of 11, that tells us that the original number wasn't divisible by 11. And if the result is 0, 0 is technically a multiple of 11, so we know that the original number was divisible by 11. Let's look at the number in our problem. We knew that either Q was 3 or Q was 7. Let's take a look at what happens when Q equals 3. If Q equals 3, that means that our number is 877,530, P76,536. Let's take a look at the alternating sums. If we start with the 8, that sum is going to be 8 plus 7 plus 3 plus P plus 6 plus 3, which gives us 27 plus P. If we look at the other set of alternating digits, that gives us 7 plus 5 plus 0 plus 7 plus 5 plus 6, which ends up becoming 30. And if we take the difference of these two, we end up getting P minus 3. We need this to be a multiple of 11. Because P has to be a digit between 0 and 9, the only possibility here is P equals 3. So we know that P equals 3 and Q equals 3 as well. If we were to have tried Q equals 7 and done the same thing, taking the alternating sums and taking the difference between them, the result would have ended up being P plus 1. And unfortunately, P plus 1 can't be a multiple of 11 if P has to be between 0 and 9. So that's not a possibility, and we know that P has to be 3, and Q also has to be 3. That means that our final number has to be 877,530, 376,536. And if you use a calculator, you can see that this number is divisible by 12, which ends up being answer choice B.